Look up at the night sky. It's something humans have done for thousands of years, gazing at the stars, tracing constellations, and wondering what lies beyond our world. We've built telescopes, launched probes, and sent astronauts into the void, all in an effort to understand the cosmos. And yet, despite all our knowledge, the universe remains full of secrets. Some of the most profound mysteries aren't just unanswered questions, they are cosmic anomalies. Phenomena so strange they defy everything we thought we knew about space, time, and reality itself. What if our entire understanding of the universe is built on incomplete truths? What if some of the most fundamental laws of physics are not laws at all, but merely suggestions in a cosmos that operates by rules we can't yet comprehend? Across the vastness of space, there are objects and events that challenge our most brilliant minds, black holes that shouldn't exist, stars that vanish without a trace, signals from deep space with no discernible source, and structures so enormous they seem to break the very fabric of reality. In this video, we're journeying into the heart of these deep space puzzles. We'll explore 25 cosmic anomalies that continue to baffle astronomers and ignite the imaginations of scientists and dreamers alike. From unexplained radio bursts traveling billions of light years to galaxies that spin in ways physics says they shouldn't, each of these phenomena raises more questions than answers. But that's what makes this exploration so thrilling. It's not just about what we know, it's about what we have yet to discover. So settle in, open your mind, and get ready to question everything you thought you understood about the universe. Our journey into the cosmos's deepest mysteries begins not with something we can see, but with an invisible force we can only feel. Our galaxy, the Milky Way, is not sitting still. It's racing through the universe at an astonishing speed of over 2 million kilometers per hour. But for the longest time, astronomers were puzzled. What could possibly be pulling us with such tremendous force? The answer, or at least the name we've given it, is the Great Attractor. This colossal gravitational anomaly lies roughly 250 million light-years away in the direction of the Norma constellation. Its power is so immense that it's not just tugging on our galaxy. It's pulling entire clusters of galaxies in a vast river of motion known as the Laniakea supercluster. Think of it as the gravitational heart of our local universe, a central point around which everything, including us, is slowly swirling. But here's where the mystery truly deepens. The Great Attractor lies directly behind the plane of our own Milky Way, a region astronomers call the zone of avoidance. This area is so thick with cosmic gas, dust, and the blinding light of billions of stars that our optical telescopes simply cannot see through it. It's like trying to peer through a dense, endless fog. For decades, this hiding place kept the Great Attractor's true nature completely secret. We knew something was there by its gravitational pull, like feeling the wind from an unseen storm, but we were blind to its source. Thanks to instruments that can see in other wavelengths, like radio and X-ray telescopes, we've begun to pierce that veil. We now know the Great Attractor is likely a massive confluence of matter, a supercluster of galaxies itself. But even that might not be the full story. Some scientists speculate that there could be something even larger and more massive behind it, continuing to pull the Great Attractor itself. This begs a profound question. Are we being drawn toward a single point, or are we simply caught in a cosmic current flowing toward an even greater unknown? Now, let's travel from a point of immense gravitational pull to a place of staggering emptiness. If the Great Attractor represents a mysterious concentration of matter, the Boötes Void is its polar opposite, a terrifying expanse of almost nothing. Discovered in the 1980s, this spherical region of space is a staggering 330 million light-years across. To put that incomprehensible scale into perspective, if you placed our Milky Way at the center, you'd have to travel through emptiness for hundreds of millions of years before you even reached the edge. In a universe that is supposed to be broadly uniform, where matter is distributed somewhat evenly. The Boötes Void is a glaring exception. This colossal sphere should contain tens of thousands of galaxies. Instead, astronomers have only found a few dozen. It is one of the largest known voids in the entire observable universe, a true desert on a cosmic scale. The existence of such a void challenges our understanding of the Big Bang and the formation of the universe's structure. How could a region so vast end up with so little? One theory suggests that countless smaller voids merged over billions of years, like soap bubbles combining to form one gigantic empty pocket. Another, more speculative idea is that the void could be the result of an advanced civilization on a scale we can't imagine, having somehow consumed all the matter within it, a concept known as a Type 3 Kardashev civilization, though most scientists consider this highly unlikely. The few galaxies that do exist within the Boötes Void are fascinating in their own right. They are isolated islands in a sea of darkness, evolving in profound isolation from the rest of the universe. Studying these lonely galaxies might teach us how galactic evolution works without the influence of neighbors. The void's emptiness also forces us to confront the true nature of space itself. Is it truly empty, or does it contain some form of dark energy or matter we have yet to detect? The Boötes Void stands as a silent, dark reminder of how much of the universe is not just unknown, but perhaps entirely unlike anything we expect. From the unsettling emptiness of the Boötes Void, we now turn to two anomalies that challenge our understanding of the universe's very structure and movement. These are not just puzzles about what is or isn't there. They are questions about the fundamental rules that govern all of existence, and they suggest that our entire cosmic neighborhood might be caught in a current we cannot see, heading toward a destination we cannot imagine. First, let's talk about dark flow. Imagine tossing a handful of leaves into a river. They'll all drift together, carried by the current. Now, picture that on a scale so vast it defies comprehension. Astronomers have observed something similar happening to entire clusters of galaxies. These massive structures, each containing thousands of galaxies, are not just moving apart due to the expansion of the universe. They are also drifting together in a specific, coordinated direction at incredible speeds of over 3 million kilometers per hour. This motion is like a cosmic wind, and it's utterly inexplicable. Here's the real mystery. This flow can't be explained by anything within our observable universe. The gravitational pull from all the matter we can see, all the galaxies, clusters, and dark matter we've mapped, is simply not enough to account for this massive, coordinated movement. It's as if these galaxy clusters are being tugged by something immense lying far beyond the edge of everything we can see. The leading, and truly mind-bending, theory is that this dark flow is caused by the gravitational influence of a structure so huge it exists outside our cosmic horizon. This means the mass concentration pulling on us is from a region of space whose light has not had enough time to reach us since the beginning of the universe. We are feeling the gravity of something we can never see, a shadow from a realm forever hidden from us. If the concept of dark flow feels like it's pulling the rug out from under our understanding of the cosmos, then the next anomaly, nicknamed the Axis of Evil, feels like it's setting the rug on fire. This one takes us back to the very beginning, to the afterglow of the Big Bang itself, the cosmic microwave background, or CBM. This faint radiation is the oldest light in the universe, a snapshot of the infant cosmos, and it's supposed to be the ultimate proof that the universe is isotropic. That's a key scientific principle stating the universe should look the same in every direction, with no special place or preferred axis. But when scientists meticulously analyzed the CBM data from the Planck satellite, they found something deeply unsettling. The fluctuations in this ancient radiation, the hot and cold spots that show the seeds of all future structure, aren't completely random. They appear to be aligned or correlated with the plane of our own solar system and the motion of our solar system through space. It's as if the universe's blueprint has a faint but undeniable signature that points directly at us. This is profoundly strange because it violates the cosmological principle. The universe shouldn't care about our little solar system. It shouldn't have a special axis that just happens to line up with our own backyard. The implications are staggering. It could mean there is something fundamentally wrong with our models of the universe's infancy. Perhaps our understanding of gravity or physics on the largest scales is incomplete. Or, in the most extreme interpretation, it could suggest that our place in the cosmos is not as ordinary as we thought, that we exist in a special location. A possibility modern cosmology has desperately tried to avoid since the days of Copernicus. While some scientists argue the alignment is a statistical fluke or a subtle error in measurement, the anomaly persists, a quiet but persistent whisper in the data that suggests our universe might have a preferred direction after all. Moving from the unsettling alignments of the cosmos to a singular, fleeting moment of contact, our next anomaly isn't a vast structure or a fundamental flaw in physics, but a tiny blip of data that has echoed through the decades. It is perhaps the most famous signal in the history of the search for extraterrestrial intelligence, a hopeful whisper that has never been repeated. This is the story of the Wow signal. On a warm summer evening in Ohio on August 15, 1977, the Big Ear radio telescope at Ohio State University was dutifully scanning the skies as part of the ongoing SETI project. Its mission was to listen for any narrowband radio signals, the kind that natural cosmic objects rarely, if ever, produce, but that an artificial transmitter would. Just after 11:16 p.m., the telescope's sensors picked up something extraordinary, a burst of intense radio waves exactly at the frequency scientists had predicted an alien civilization might use, 1420 megahertz, a quiet channel protected from interference by international agreement, right near the famous hydrogen line. The signal was unlike anything the telescope had recorded before. It was a pure, strong, narrowband radio transmission that rose to peak intensity over 72 seconds, the exact amount of time it takes for a fixed point in the sky to pass through the Big Ear's stationary, bowl-shaped receiver, and then faded away. It was a perfect bell curve on a printout. A few days later, a young astronomer named Jerry Amon was reviewing the computer printouts, a routine task of sifting through reams of alphanumeric data, where each signal's strength was represented by a number or a blank space. When his eyes landed on this particular sequence, 6EQUJ5, he was stunned. He circled the alphanumeric string in red pen, and in the margin simply wrote, "Wow." That single word of astonished annotation gave the signal its immortal name. The characteristics of the Wow signal are what make it so compelling and so frustrating. It came from the direction of the constellation Sagittarius, near a star group called Chi Sagittarii, in a region of the sky relatively poor in stars. The signal's frequency was almost certainly not from Earth, as that band is prohibited for terrestrial transmission. It wasn't a repeating satellite broadcast or a random burst of static. It fit every criterion for a signal of intelligent, extraterrestrial origin. And then it was gone. Despite decades of repeated, targeted searches by powerful radio telescopes like the Very Large Array, the signal has never been heard again. It was a one-time event, a cosmic door that swung open for just 72 seconds and then slammed shut forever. The mystery of its origin has fueled endless debate. The most thrilling possibility is that we briefly intercepted a deliberate beacon from a distant civilization, a lighthouse blast meant to announce their presence. Perhaps it was a piece of powerful machinery, like an immense radar or a propulsion system, that just happened to be pointed in our direction for that fleeting moment. The more sober explanation points to a natural, albeit rare, celestial event. Some have proposed it was a signal from a comet that was emitting hydrogen, though the comets in that region weren't discovered until years later, and their composition didn't quite match. Others suggest it could have been an immensely powerful and focused burst of radio energy from a passing asteroid or a phenomenon involving interstellar plasma that we don't yet understand. The enduring power of the Wow signal lies not in what it was, but in what it represents. It is a Rorschach test for our hopes and our scientific skepticism. For a brief moment, it gave us a tantalizing glimpse of a universe that might be teeming with other voices. Its singular nature is what keeps it alive as one of astronomy's greatest unsolved mysteries. It stands as a monument to the idea that we might only need to be listening at the right place, at the right time with the right technology, to hear a call from the cosmos that changes everything. It is a reminder that the universe might be speaking, and we have only just begun to learn how to listen. After that brief, tantalizing signal from the cosmos, we are left with a profound silence that is, in itself, one of the greatest anomalies of all. We've scanned the skies for decades with increasingly powerful technology, and all we've found is that mysterious one-off wow, a single, perfect note in an otherwise overwhelming quiet. This silence forces us to confront a monumental question first posed by the physicist Enrico Fermi. If the universe is so unimaginably vast and ancient, filled with hundreds of billions of stars in our galaxy alone, many of which host Earth-like planets, then where is everybody? This is the essence of the Fermi Paradox, the staggering contradiction between the high probability of alien civilizations and our total lack of any proof they exist. The numbers themselves are almost a form of proof. Our Milky Way galaxy is roughly 13 billion years old. In that time, enough stars have been born, lived, and died to seed the galaxy with the heavy elements necessary for planets and life. Conservative estimates suggest there could be tens of billions of habitable worlds in our galaxy. Even if the odds of intelligent life emerging on any one of them are astronomically small, the sheer size of the galaxy should have allowed it to happen countless times. And given the age of the galaxy, any civilization that arose just a few million years before us, a blink of an eye on the cosmic scale, would have had more than enough time to spread across the stars, colonizing entire swaths of the Milky Way. The galaxy should be teeming with life, echoing with signals, and filled with the artifacts of cosmic engineering. Yet, when we listen, we hear nothing but the faint, natural whisper of the universe. Our telescopes see no megastructures, no fleets of starships, no obvious signs of a galactic community. The silence is deafening. This paradox has given rise to a spectrum of possible solutions, some comforting, others deeply unsettling. Perhaps the most ominous idea is the Great Filter hypothesis. This theory suggests that there is some kind of barrier, a nearly insurmountable challenge, that prevents life from progressing to the stage of interstellar colonization. The terrifying question is, where is this filter? Is it behind us? Were we just incredibly, miraculously lucky to evolve at all, making our planet a unique oasis in a sterile desert? Or is the filter still ahead of us? This is the more frightening possibility. It could be that advanced civilizations inevitably destroy themselves with the technology they create, whether through nuclear war, environmental collapse, or something we haven't even conceived of yet. The silence of the cosmos in this view is a grave warning. It's the sound of countless civilizations that have already flickered out. On the other end of the spectrum are theories that are less about doom and more about perspective. The zoo hypothesis, for instance, proposes that extraterrestrial civilizations are indeed out there, and they are aware of us, but they have chosen to deliberately avoid contact. They might be observing us from a distance, much like we observe animals in a nature preserve, allowing humanity to develop naturally without interference until we reach a certain level of maturity or technological sophistication. Another idea is that we are simply looking for the wrong things. Our technology and methods for searching might be primitive compared to a truly advanced civilization. They might communicate using physics we don't yet understand, Or they might have transcended biological form entirely, existing as post-biological intelligences in realms we cannot perceive. The true weight of the Fermi Paradox isn't just in the answer. It's in how it reframes our entire place in the cosmos. It either makes our planet astonishingly rare and precious, or it places us on the precipice of a challenge that has ended every other civilization that came before us. It forces a profound humility. We are either the lone, fragile guardians of consciousness in a vast, empty universe, or we are the newcomers, the infants, unaware of the ancient, silent watchers in the dark. The paradox holds up a mirror, and in the silence we are left to wonder not about them, but about ourselves. While we search the cosmos for signs of others, sometimes the greatest mysteries come from our own creations, revealing that even within our own solar system, the laws of physics might still hold a few surprises. This brings us to the curious case of the Pioneer Anomaly, a tiny, persistent tug that defied explanation for over 30 years. In the early 1970s, humanity launched two of its most ambitious explorers, Pioneer 10 and Pioneer 11. These robust spacecraft were designed to be trailblazers, the first to journey through the asteroid belt, and the first to make close-up observations of the gas giants Jupiter and Saturn. After completing their primary missions, they continued on, becoming the first human-made objects set on a course to leave our solar system entirely. As they sailed into the deep, dark expanse beyond the orbit of Pluto, scientists back on Earth meticulously tracked their positions using Doppler radio signals. By measuring the precise frequency of the radio waves bouncing back from the spacecraft, they could calculate their speed and location with incredible accuracy. And that's when they noticed something was off. Both Pioneers were slowing down ever so slightly more than they should have been. An unknown force was acting upon them, producing a constant, sunward deceleration equivalent to just 10 billionths of the gravity we feel on Earth. To put it in perspective, it was like the spacecraft were being held back by a force no stronger than the weight of a single grain of sand. This seems insignificant, but over the vast distances of space travel, even a minuscule, unaccounted-for acceleration adds up, creating a deviation that grows over time. After a decade, the anomaly had pushed the Pioneers hundreds of kilometers off their predicted course. This wasn't a random error. It was a consistent, persistent signal in the data that simply shouldn't have been there according to Newton's laws of motion and gravity. The search for an explanation launched a decades-long scientific detective story, pitting mundane engineering explanations against the thrilling possibility of new physics. The more exotic theories were captivating. Some physicists suggested that the anomaly could be evidence of a flaw in our understanding of gravity itself, perhaps a modification of Einstein's theory of general relativity that would only become apparent in the weak gravity environment of the outer solar system. Others wondered if the spacecraft were plowing through a diffuse halo of dark matter anchored to the Sun, its gravitational drag causing the tiny but measurable slowdown. For a time, the Pioneer Anomaly was a beacon for those hoping to find a crack in the foundation of modern physics. But the true answer, as is often the case, lay not in rewriting the textbooks, but in a painstakingly detailed examination of the textbooks we already had, and the spacecraft themselves. The breakthrough came from a dedicated team that spent years recovering old data tapes, analyzing telemetry records, and even creating sophisticated thermal models of the 40-year-old spacecraft. They realized that the probes were not just cold, silent objects coasting through space. They were also subtle, complex heat engines. The electrical systems and the plutonium in their radioisotope thermoelectric generators produced a constant, low level of heat. This heat was radiated away from the spacecraft into the freezing void of space. The key insight was that this heat radiation was not perfectly symmetrical. More heat was being emitted from the back of the spacecraft, away from the Sun, than from the front. This created a tiny but very real recoil force, a photon thrust, much like the push you feel from a bright light. Because this force was directed away from the rear, it subtly pushed the spacecraft back toward the Sun, creating the exact effect of an unexplained sunward acceleration. It was the equivalent of a car idling. The engine is running and producing a faint vibration, and that vibration was ever so slowly applying the brakes. Once this thermal recoil force was meticulously calculated and factored into the models, the infamous anomaly virtually disappeared. The resolution of the Pioneer Anomaly is a powerful lesson in scientific humility. It shows us that our instruments are not perfect observers. They are physical objects that interact with their environment in complex ways. What seemed like a gateway to new physics was, in the end, a testament to the incredible precision of our models and the importance of accounting for every last detail. Yet, a tiny sliver of the anomaly remains unexplained, a whisper in the data that some researchers believe might still point to something more. It serves as a reminder that even solved mysteries can leave behind a residue of wonder, pushing us to look even closer the next time. Now, let's turn from the silent, drifting probes of our own making to an object that sailed into our solar system from the great unknown, a visitor from another star. In October 2017, astronomers at the University of Hawaii made an astonishing discovery. Using the Pan-STARRS 1 telescope, they spotted a faint point of light moving at incredible speed. Its trajectory was unlike anything they had ever seen. It wasn't orbiting the Sun. It was barreling through our solar system on a hyperbolic path, meaning it was just passing through. This was the first ever confirmed interstellar object, and they named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. From the very beginning, Oumuamua was an enigma. As telescopes around the world swiveled to track it, they struggled to pin down its basic properties. The first major surprise was its shape. By observing how its brightness changed dramatically over periods of hours, astronomers deduced that it wasn't a sphere. It was tumbling through space, and its light curve suggested an extremely elongated, cigar-like object, estimated to be up to 10 times longer than it was wide. Nothing like this exists in our own solar system, where most asteroids and comets are far more rounded. It was a shape that seemed almost engineered. The second major puzzle was what it was made of. Initially classified as an asteroid due to the lack of a visible coma, the fuzzy cloud of gas and dust that surrounds a comet's nucleus, this classification soon became a problem. As Oumuamua rounded the Sun and began its journey back out into interstellar space, something extraordinary happened. Precise measurements showed it was accelerating, ever so slightly, in a way that could not be explained by the Sun's gravity alone. This is known as non-gravitational acceleration, and it's a classic hallmark of cometary activity. The heat from the Sun vaporizes ices on the surface, creating jets of gas that act like tiny thrusters, pushing the object. But Oumuamua displayed no visible outgassing, no tail, no dust cloud. It was accelerating as if it were a comet, but it looked nothing like one. This bizarre combination of traits, the strange shape, the lack of a coma, and the mysterious non-gravitational acceleration, sent astronomers scrambling for explanations. The most natural theories propose it is a rare type of icy body. One compelling idea is that it could be a hydrogen iceberg. In the coldest, densest reaches of interstellar space, molecular hydrogen could freeze solid. As this hydrogen iceberg neared the Sun, the warmth would cause the frozen hydrogen to sublimate, providing the thrust for the acceleration without producing a visible dust tail, as hydrogen is invisible. However, many question whether such a fragile object could have survived a long journey through interstellar space. Another hypothesis suggests it is a nitrogen iceberg, a chunk that was likely sheared off from a Pluto-like exoplanet billions of years ago. The acceleration could be explained by the sublimation of nitrogen ice, which, like hydrogen, wouldn't produce a dusty coma visible to our telescopes. While this is a more robust material than hydrogen, it still requires a very specific and rare formation history. Then, of course, there is the more sensational, though far less probable, theory put forward by Harvard astronomer Avi Loeb. He posited that Oumuamua's unusual acceleration and peculiar shape could be consistent with a light sail, a thin, artificially made object designed to be pushed by the radiation pressure from starlight. In this scenario, it would be a piece of advanced technology, either a derelict probe or a purposeful scout, sent from another civilization. While this idea captured the public's imagination, the vast majority of the scientific community maintains that an exotic natural explanation is far more likely. The universe has had billions of years to cook up strange objects we've never seen before. We shouldn't immediately assume intelligence is the cause. What makes Oumuamua a truly enduring cosmic anomaly is that we may never know the answer. It is now far beyond the reach of our telescopes, speeding into the void. We had only a few precious weeks to observe it, and the data we collected is all we will ever have. It defies easy classification because it is a sample of an entirely different planetary system, formed around another star under conditions we can only guess at. Its very existence tells us that interstellar space is likely filled with such wanderers, and each one could be a fragment of a world we have never imagined. Oumuamua was a brief, cryptic postcard from a distant cosmic shore, a reminder that the galaxy is not only vast, but also teeming with forms of matter we are only beginning to understand. While the silent, drifting pioneers and the fleeting visitor Oumuamua presented puzzles we could study up close, some of the most baffling anomalies are found by staring intently at a single, distant point of light. This brings us to one of the most enduring modern cosmic mysteries, a star whose bizarre behavior has resisted explanation for years and ignited a firestorm of scientific debate and public imagination. Its official designation is KIC 8462852, but the world knows it as Tabby's star, named after the astronomer Tabby, who led the team that first brought its strangeness to light. And it's a strangeness that is all about missing light. The story begins with NASA Kepler Space Telescope, a mission designed to find planets by staring at one patch of sky for years, monitoring the light from over 150,000 stars. It was looking for the telltale, periodic dimming that occurs when an exoplanet passes in front of its host star. Most dips are tiny, orderly, and predictable. But then there was Tabby's star. The data from Kepler revealed dimming events that were absolutely unprecedented. This wasn't the gentle, rhythmic blink of a planet. This was chaos. The star experienced a series of deep, irregular dimming events. On several occasions, its light output dropped by a staggering 20%. To put that in perspective, a Jupiter-sized planet, the largest in our solar system, would only block about 1% of a sun-like star's light. Something 20 times larger than Jupiter would be needed to create a dip that deep. But it gets even stranger. The dimming wasn't consistent. The dips varied wildly in their depth, their duration, and their timing. Some lasted for days, others for weeks. There was no pattern, no regular interval that would point to a simple orbital cause. Furthermore, long-term studies of historical astronomical plates showed that, over the past century, the star's overall brightness has also mysteriously faded by a significant amount. This was a multi-layered enigma. Sharp, deep, aperiodic dips superimposed on a long, slow, secular dimming. When natural phenomena behave in ways that defy easy explanation, the human mind naturally leaps to extraordinary possibilities. And so was born the most famous hypothesis about Tabby's star, the alien megastructure. The idea, popularized by astronomers like Jason Wright, was that we might be witnessing the construction of a Dyson sphere, or more likely, a Dyson swarm. This is a hypothetical colossal array of energy, collecting satellites or platforms that an advanced civilization would build around its star to harness virtually all of its power output. If such a project were underway, the incomplete, irregular swarm of constructs passing in front of the star could perfectly explain the bizarre, deep, and unpredictable dimming patterns. It was a breathtaking notion that our telescopes might have inadvertently spotted the largest engineering project ever conceived, over 1,000 light-years away. The scientific community, of course, immediately embarked on a furious search for more conventional answers. The leading natural theory proposed a massive, fragmented swarm of comets. The idea was that a family of exocomets, perhaps disturbed by a nearby star, had been drawn in close to Tabby's star. As they broke apart, they would create a vast, dusty cloud of debris with a highly irregular structure, which could account for the deep and erratic transits. Others suggested the debris from a cataclysmic planetary collision, like the one that formed our moon but on a far grander scale, leaving a cloud of pulverized rock and dust to periodically blot out the star. Subsequent observations have lent more weight to these natural explanations, particularly those involving dust. When astronomers used the Las Cumbres Observatory Global Telescope Network to catch the star in the act of dimming, they were able to analyze the specific colors of light that were being blocked. They found that the star dims more in blue light than in red light. This is a crucial clue. Small dust grains scatter blue light more effectively, which is exactly what was observed. A solid object, like an alien megastructure or a planet, would block all colors of light equally. This finding strongly suggests that whatever is blocking the light is not solid, but made up of tiny particles, most likely circumstellar dust. Yet, the mystery is not fully solved. While dust seems to be the primary culprit for the short-term dips, the cause of the long-term, century-long dimming remains an open question. The irregularity of the transits also means we still don't know what mechanism could create such a vast and chaotic cloud of dust in the first place. The comet swarm idea, while plausible, requires an almost impossibly large number of comets to be invoked. Tabby's star stands as a powerful example of how science works in the real world. An initial, shocking anomaly leads to a thrilling hypothesis, which in turn drives more detailed observation. Those observations then narrow down the possibilities, often ruling out the most exotic ideas in favor of more natural, albeit still fascinating ones. We may have moved away from the dystopian sphere, but we are left with a stellar phenomenon unlike any other, a cosmic puzzle that reminds us that the universe is still perfectly capable of keeping its most fascinating secrets. This discovery throws a massive wrench into our most fundamental understanding of how galaxies work. For decades, the prevailing model of galaxy formation, known as the lambda cold dark matter model, has placed dark matter as the absolute cornerstone. We believe that after the Big Bang, dark matter collapsed first, forming vast, invisible halos. It was the gravitational scaffolding, the cosmic framework, upon which normal, baryonic matter, the gas and dust that make up stars and planets, could then accumulate. Without this dark matter anchor, the regular matter from the primordial universe would have simply flown apart due to its own angular momentum. It never could have clumped together to form the magnificent structures we see today. Every galaxy we had studied, from the smallest dwarf to the largest elliptical, seemed to be embedded within and dominated by its own halo of dark matter. It was considered an inseparable, fundamental part of a galaxy's identity. So, the existence of NGC 1052 DF2 creates a fascinating paradox. It presents astrophysicists with two equally revolutionary possibilities, and both would fundamentally reshape our cosmic perspective. The first possibility is the most shocking, that dark matter doesn't actually exist. If a galaxy can form and hold itself together without any need for this mysterious substance, then perhaps our entire theory of gravity is wrong. This idea isn't new. It's called modified Newtonian dynamics, or MND. Proponents of MND suggest that on very large galactic scales, gravity behaves differently than the laws laid out by Newton and Einstein predict, creating the illusion of unseen mass. A galaxy without dark matter could be the ultimate proof that Mund is correct, that we've been chasing a phantom for decades and need a complete rewrite of physics. The second possibility is, in its own way, even more validating for the Standard Model. The existence of NGC 1052 DF2 could actually prove that dark matter is a real, physical substance that can be separated from normal matter. How could this happen? The leading theory involves a dramatic galactic collision billions of years ago. Imagine two nascent galaxies in the early universe, each with its own dark matter halo and its own collection of gas and stars. If they pass through each other in just the right way, the dark matter, which doesn't interact with itself or other matter except through gravity, could have sailed right through, unaffected. The regular matter, the gas and dust, would have collided, experiencing friction and hydrodynamic forces, slowing down and getting stuck in the middle of the interaction. The result would be a galaxy like DF2, born almost entirely from the collisional debris of that ancient crash, and thus completely devoid of the dark matter that originally nurtured its components. In this scenario, DF2 isn't a refutation of dark matter. It's the strongest evidence yet that dark matter is a distinct, tangible substance that behaves exactly as physicists have predicted. The debate, of course, rages on. Follow-up studies have both supported and challenged the initial findings. Some teams have published conflicting distance measurements for the galaxy, arguing that if it's closer to us than originally thought, its stars would be intrinsically dimmer, its total mass would be lower, and the anomaly might disappear. The original team, however, has held firm with their distance calculations and even doubled down by discovering a second, similar galaxy, NGC 1052 DF4, which also appears to be missing its dark matter. This suggests that while incredibly rare, DF2 is not a singular fluke. The true legacy of this ghostly galaxy may not be a single, definitive answer, but the profound questions it forces us to ask. It acts as a crucial cosmic experiment, a natural laboratory that tests the very limits of our theories. Whether it ultimately proves dark matter is separable or forces us to invent a new theory of gravity, its very existence demonstrates that the universe still has profound lessons to teach us about the nature of reality itself. It proves that dark matter is not some vague mathematical fudge factor. It is something that can be present or startlingly absent with dramatic consequences. But perhaps the most spectacular way a black hole can reveal itself is not by staying put, but by going on the run. We tend to think of supermassive black holes as the unmovable anchors at the heart of every galaxy, but the universe has a way of upending our expectations. This brings us to a truly breathtaking discovery: a supermassive black hole weighing as much as 20 million suns that has been violently ejected from its own galaxy and is now hurtling through intergalactic space at phenomenal speed. And in its wake, it is not leaving destruction, but a stunning and improbable trail of newborn stars. The story begins with the Hubble Space Telescope, which captured an image that initially baffled astronomers. It showed what looked like a brilliant, almost scratch-like streak of light stretching away from a distant galaxy. At one end of this cosmic contrail was the galaxy itself. At the other end was a blazing, bright quasar, the intensely energetic signature of an active supermassive black hole greedily feeding on surrounding matter. The most logical conclusion was that this was a jet of material being shot out from the black hole. But the more they analyzed it, the more that explanation fell apart. The streak wasn't a jet of high-energy particles. Its spectrum revealed it was composed of ionized oxygen, and crucially, it was pointing directly back to the heart of the galaxy. This wasn't a jet being ejected from the black hole. This was a wake being left behind by the black hole itself as it fled. So how does something with the gravitational pull of 20 million stars get kicked out of its home? The answer lies in the ultimate cosmic showdown, a merger. Galactic collisions are common throughout the universe. When two galaxies merge, their central supermassive black holes eventually sink to the new common center through a process called dynamical friction. There, they begin to orbit each other, forming a binary pair. This dance continues for eons, but when a third galaxy, and thus a third black hole, joins the party, the stable system is thrown into chaos. The intricate gravitational interactions between three massive objects are incredibly complex and unstable. Through a process known as the gravitational slingshot effect, one of the black holes can be flung out of the galactic center at immense speed, like a stone from a sling. In this case, the ejected black hole was likely the lightest of the three, catapulted away by its more massive siblings. The most beautiful and unexpected part of this story is not the violence of the ejection, but the creativity it spawned. As the black hole tears through the circumgalactic medium, the thin halo of gas that surrounds a galaxy, it isn't just plowing through emptiness. It's moving so fast at over 5 million miles per hour that it slams into this diffuse gas. The shock of its passage compresses the gas in front of it, and the incredible tidal forces generated by its immense gravity further stir and agitate the material. This process triggers a runaway collapse of cold gas clouds, seeding the conditions for rapid star formation. The black hole becomes a cosmic plow, tilling the barren fields of intergalactic space and sowing them with the seeds of new solar systems. The brilliant trail we see is not a path of ruin. It is a 200,000 light-year-long stellar nursery, a river of newborn stars left in the wake of a celestial exile. This discovery does more than just add a new curious object to the cosmic catalog. It provides a living demonstration of some of the most extreme physics in the universe. It offers direct evidence that supermassive black holes can indeed be ejected from their galaxies, a prediction of Einstein's general relativity that had been largely theoretical until now. It shows us that the centers of merging galaxies are arenas of incredible violence, where the most massive objects we know of are tossed around like mere playthings. Furthermore, it reveals a novel mechanism for star formation, one not tied to the gentle collapse of a gas cloud within a galaxy, but to the violent, shock-induced birth triggered by a runaway gravitational titan. This lone black hole racing through the darkness is a testament to the fact that even in the most chaotic and destructive events, the universe has a mysterious tendency to create. Just when we thought we had cataloged the strange and spectacular sights of the cosmos, the universe unveiled a brand new mystery, one that seemed to appear out of nowhere. In 2020, astronomers using the revolutionary Australian Square Kilometre Array Pathfinder, or ASCAP, radio telescope were mapping the sky at radio wavelengths when they stumbled upon something utterly baffling. They found faint, ghostly circles of radio light scattered across the heavens. They were so strange and so unlike anything ever seen before that the researchers, with a touch of scientific humor, simply named them odd radio circles, or ORC. And the name has stuck, perfectly capturing their enigmatic nature. The first and most startling thing about an ORC is what it isn't. It is a ring, a perfect circle of diffuse radio emission, but it is completely invisible. If you point an optical telescope, an infrared telescope, or an X-ray telescope at its exact location, you will see nothing. It is a celestial ghost, a structure that only reveals itself through the faint whisper of radio waves. The second astounding feature is its sheer, mind-boggling scale. A single ORC is enormous, with a diameter of about 1 million light-years. To comprehend that size, consider that our entire Milky Way galaxy is a mere 100,000 light-years across. One of these circles is so vast it could easily swallow 10 galaxies the size of our own. They are truly intergalactic structures, existing on a scale that dwarfs nearly everything else we study. Naturally, the immediate challenge was to figure out what in the universe could possibly create such a massive, perfectly circular, and invisible structure. The first and most logical suspicion was that it was some kind of remnant from a stellar explosion, a supernova. But that idea was dismissed almost instantly. A supernova remnant is a tiny, local event on this galactic scale. An ORC is 1,000,000 times larger. Others wondered if it could be the circular shockwave generated by a gamma-ray burst, but again, the size was all wrong. These circles were in a league of their own. Astronomers have since proposed several compelling, yet still unproven, hypotheses. One leading idea points the finger at galactic winds. In the heart of a starburst galaxy, where stars are being born at a ferocious rate, the combined effect of supernova explosions and stellar winds can create a powerful outflow, a galactic-scale hurricane of material blasting outwards in all directions. This shockwave could travel for hundreds of thousands of light years, creating a massive, spherical bubble that glows in radio waves as it interacts with the tenuous material between galaxies. This would explain the circular shape and the radio emission, but it requires a truly titanic amount of energy, pushing our understanding of galactic mechanics to its limit. Another, far more exotic theory suggests that we might be looking at the throat of a wormhole. According to some speculative physics, a traversable wormhole, a hypothetical tunnel through spacetime, could be surrounded by a sphere of concentrated energy. If such a structure were to exist, it might just manifest as a perfect circle to our telescopes. While this is a thrilling notion straight out of science fiction, most scientists consider it the least likely explanation, preferring to exhaust all natural possibilities first. Perhaps the most promising theory connects ORCs to the most violent events in the universe, the merger of two supermassive black holes. When the black holes at the centers of two colliding galaxies finally spiral together and coalesce, they release an unimaginable burst of gravitational wave energy. This energy is not emitted equally in all directions. It is shot out in two narrow, incredibly powerful jets moving at nearly the speed of light. Now, imagine if one of these jets was pointed directly at Earth. We would see it as a brilliant blazar or quasar. But if we are viewing the system from the side, from a 90-degree angle, our perspective changes completely. We would be looking down the barrel of the jet, seeing the immense, spherical shockwave it created as it plowed into the intergalactic medium. This would present itself as a perfect, radio-emitting ring surrounding the entire galaxy, a cosmic pulse, left over from a monumental collision that occurred eons ago. The truth is, we still don't know for certain what ORCs are. They represent a brand new class of astronomical object, a discovery that reminds us that our maps of the universe are still incomplete. Every new telescope, every new way of looking at the sky, has the potential to reveal phenomena we never even dreamed of. The ORCs are a message from the cosmos, a signal that even in an age of advanced technology, the universe still holds profound surprises waiting just beyond the edge of our current understanding. From the colossal, newly discovered odd radio circles, we now turn our gaze to a far smaller, yet no less perfect, geometric wonder. In a universe dominated by spiraling galaxies, spherical stars, and chaotic clouds, one nebula stands out for its breathtaking and utterly unnatural precision. In the constellation Monoceros, the unicorn, lies a cosmic jewel box known as the Red Rectangle Nebula. It is a sight that immediately prompts a double take. Through the lens of the Hubble Space Telescope, it doesn't look like a cosmic object at all. It appears instead as a meticulously crafted piece of art, a glowing, crimson-hued lattice of concentric rectangles, all leading to a brilliant X shape at its heart. It is so geometrically perfect that it seems impossible it wasn't made by intelligent design. The central engine of this beautiful anomaly is a binary star system known as HD 44179. These two aging stars are locked in a tight orbital dance, and they are the architects of the surrounding spectacle. As these stars evolve, they begin to shed their outer layers, casting off vast quantities of gas and dust into the space around them. This is a common process. It's how many planetary nebulae are born. But here, the result is anything but common. Instead of a billowing, irregular sphere or a complex butterfly shape, the ejected material has organized itself into this astonishingly symmetrical structure. So how does the chaotic fury of a dying star give rise to something with such sharp angles and precise lines? The leading theory points directly to the orbital dynamics of the binary pair. Astronomers believe that the dense torus, a donut-shaped ring of dust, surrounds the two central stars. This dust ring effectively pinches the outflowing gas, constricting it and forcing it to shoot out perpendicular to the ring's plane, above and below the stars. This creates two opposing cones of material. Now, imagine our line of sight. We are viewing this binary system almost directly edge-on. When you look at the base of two cones placed tip to tip from this side on perspective, the outline you see is a perfect X. The concentric rectangular rings are thought to be waves of material, almost like ripples on a pond, ejected in pulses during the star's death, throes and illuminated by their intense ultraviolet light. Yet, even this elegant explanation leaves lingering questions. The mechanism produces the general X shape, but the razor-sharp, almost laser-cut perfection of the rectangles remains a subject of intense study. The precise physics that sculpts the dust grains and ionizes the gas to create such clean, linear boundaries in the vacuum of space is not fully understood. Furthermore, the deep red color, which gives the nebula its name, is another clue to its unique nature. This crimson glow comes from a specific type of carbon-based molecule known as polycyclic aromatic hydrocarbons, or PA. These are complex organic compounds that fluoresce in red light when bathed by the star's ultraviolet radiation. The presence of these building blocks of life, being mass-produced and ejected in such a structured manner, adds another layer of fascination to this object. The Red Rectangle Nebula is more than just a cosmic curiosity. It is a natural laboratory for studying the death of solar systems and the creation of complex molecules. It demonstrates that under the right conditions, the laws of physics and orbital mechanics can produce results of breathtaking symmetry and mathematical beauty. It is a powerful reminder that the universe is not always chaotic. It can also be a place of immense order and precision, creating geometric wonders that rival the most careful human design. This dying star system is meticulously crafting its own memorial, a glowing, red, rectangular masterpiece that will eventually disperse, seeding the interstellar medium with the organic compounds for future worlds. While our journey has taken us to the farthest reaches of the cosmos, some of the most striking anomalies are waiting right in our own celestial backyard, wrapped in the beautiful, swirling bands of a gas giant. High above the North Pole of the planet Saturn, a storm is raging. But this is no ordinary tempest. For over 4 decades, since it was first glimpsed by the Voyager probes in the 1980s, and later studied in stunning detail by the Cassini spacecraft, a perfect, gargantuan hexagon has dominated the atmospheric landscape. This 6-sided jet stream, wider than 2 Earths placed side by side, is a geometric wonder etched into the clouds, with a terrifying, rotating hurricane spinning precisely at its center. It is a structure of such mathematical precision that it seems to defy the very nature of chaotic weather. The mystery of the hexagon isn't that it exists, but that it persists. Planetary atmospheres are the definition of fluid dynamics, governed by turbulence and constant change. On Earth, even our most powerful storms dissipate after a few weeks. Yet Saturn's hexagon has remained locked in place, its 6 sides strikingly sharp and its pattern unwavering, for at least 40 years and likely much longer. It is a permanent feature on a world of tempests, a piece of atmospheric architecture that has outlasted every hurricane and cyclone our planet has ever produced combined. This incredible longevity is what truly separates it from any other weather pattern we've observed. Scientists have a leading theory for its formation, and it's one we can witness on a much smaller scale right here at home. If you place a fluid in a rotating bowl and spin it at just the right speed, you can actually create standing waves with multiple sides: a square, a triangle, or even a hexagon. This is a classic demonstration of how fluids behave under rotation and shear. Researchers believe that deep within Saturn's atmosphere, different layers of gas are moving at wildly different speeds, creating a steep latitudinal gradient in atmospheric winds known as a jet stream. It is thought that this particular jet stream has instabilities that generate a standing wave, which then manifests as this six-sided pattern. The number of sides is likely determined by the specific speed and depth of this atmospheric river. But while the basic principle seems sound, the devil is in the dizzying details. Laboratory experiments and sophisticated computer simulations have managed to create hexagonal shapes in spinning fluids, but they consistently fail to replicate the sheer stability and the razor-sharp boundaries of Saturn's version. The models often produce shapes that are blurry, that drift, or that eventually break down. Saturn's hexagon is unnervingly rigid and persistent. This suggests there are factors at play that we haven't yet accounted for in our models. The incredible depth of Saturn's atmosphere, which extends thousands of kilometers down to a possible rocky core, could be a key ingredient. The hexagon might not be a shallow weather pattern, but a phenomenon that is anchored deep within the planet's interior. Its shape and stability influenced by dynamics occurring far beneath the cloud tops we can see. Furthermore, the entire structure rotates with a period of about 10 hours and 39 minutes, which itself is a puzzle. This period is believed to be the true rotation rate of Saturn's deep interior, suggesting the hexagon is a window straight into the heart of the giant, a visible clock face on a world that otherwise has no solid surface to measure. The rotating storm at its center adds another layer of complexity, with eye walls towering higher than any hurricane on Earth and wind speeds exceeding 300 miles per hour. How this central vortex interacts with and is contained by the hexagonal jet stream remains an active area of study. The Saturn hexagon stands as a humbling reminder that even within our own solar system, the physics of planetary weather can produce breathtaking and enduring mysteries. It is a natural experiment in fluid dynamics operating on a scale we can never hope to recreate, a testament to the beautiful and often unexpected order that can emerge from chaos. It proves that you don't need to look for alien megastructures to find something that challenges your perception. Sometimes, you just need to look at a familiar planet in an entirely new light. Leaving behind the geometric perfection of Saturn's hexagon, we now venture into the darkest and most mysterious realm of cosmic objects, where the laws of physics are pushed to their absolute limit. But we're not looking for a monster. In fact, we're hunting for something incredibly small, so tiny and faint that it has remained hidden in plain sight. This brings us to a recent and astonishing discovery, a cosmic needle in a haystack that challenges the very definition of a black hole itself. Its official name is a jumble of letters and numbers, but astronomers have given it a far more fitting and mythical title: the unicorn. This particular black hole wasn't found by observing the violent destruction of a star or the brilliant glow of an accretion disk. It was discovered by noticing a subtle, rhythmic wobble in a nearby red giant star. Located just 1,500 light-years away in the constellation Monoceros, which, fittingly, is Latin for unicorn, this red giant was behaving strangely. As astronomers tracked its motion, they noticed a slight but consistent shift in its light, a telltale sign that an unseen companion was gravitationally tugging on it, causing it to wobble back and forth as they orbited a common center of mass. The orbit was incredibly fast, completing a full revolution in less than 6 months, indicating the companion had to be extremely massive for its size. Yet, when they pointed every available telescope at the spot where this massive object should have been, they saw absolutely nothing. No light, no X-rays, no radio waves. The only thing that could be both so massive and so completely invisible is a black hole. But the math revealed something that, according to many models, shouldn't even be possible. The unicorn is a stellar mass black hole, but it exists on the far lower edge of the scale. Estimates place its mass at roughly 3 times that of our Sun. This might not sound particularly small, but in the world of black holes, it is profoundly diminutive. It sits right at the theoretical precipice, challenging our understanding of how these objects form. Black holes are born from the catastrophic collapse of the most massive stars. When such a star exhausts its nuclear fuel, its core collapses under its own immense gravity. If the core is heavy enough, the collapse continues unchecked, crushing matter into an infinitely dense point, a singularity, and creating a black hole. For decades, astrophysicists have worked to define the lower mass limit for this process. They calculated that the gravitational collapse of a star's iron core should inevitably produce a black hole no smaller than about 5 solar masses. Anything smaller, the theory went, would result in a neutron star, a city-sized ball of ultradense matter that just barely avoids becoming a black hole. The existence of a 3-solar mass black hole throws a wrench into this clean division, forcing us to ask, is our lower limit wrong, or did the unicorn form in a way we haven't considered? This is where the discovery moves from a curious oddity to a potential gateway for a hidden population. If one such tiny black hole exists so close to us, there must be countless more scattered throughout the galaxy. A vast unseen archipelago of small black holes that have simply escaped our notice. They are the cosmic ghosts, too small to create the dramatic feeding events that make their larger cousins visible, and too dark to be seen directly. Their primary method of detection is exactly how the unicorn was found, through their gravitational influence on a binary companion star. This revelation opens up an entirely new hunting ground for astronomers. By carefully monitoring the subtle wobbles of millions of stars across the galaxy, we might begin to uncover this hidden demographic, painting a much more complete picture of stellar death and the final remains left behind. The implications are profound. The unicorn might represent a previously overlooked channel of black hole formation. Perhaps it wasn't born from the collapse of a single massive star, but is instead the product of a merger between 2 neutron stars in a binary system. If their combined mass exceeded a critical threshold, they could have collapsed directly into a black hole, bypassing the traditional stellar core collapse model entirely and landing squarely in this mysterious mass gap. Its existence forces a re-evaluation of the final moments of a star's life, suggesting that the boundary between neutron star and black hole is far messier and more complex than our textbooks once claimed. This tiny, dark object, hiding beside a glowing red giant, proves that even the most extreme objects in the universe can come in surprising packages, and that the hunt for the unknown often requires looking not for the bright and obvious, but for the faintest of whispers in the data. After exploring the unicorn, a black hole hiding in our cosmic neighborhood, we now shift our gaze to a far grander and more frigid mystery, one that takes us back to the very dawn of time. In the afterglow of the Big Bang, the cosmic microwave background radiation blankets the entire sky. This ancient light is our most precise map of the infant universe, and for the most part, it's remarkably uniform, a tapestry of tiny temperature fluctuations that represent the seeds of all future galaxies. But there is one glaring exception, a feature so large and so cold it stands out like an icy thumbprint on the warm fabric of the cosmos. This is the cosmic cold spot, a region in the constellation Eridanus that is significantly colder than its surroundings, stretching over 1 billion light-years across. The sheer size of this anomaly is the first clue that something is deeply unusual. The standard cosmological model predicts that temperature variations in the CMB should be random and relatively small scale, the result of quantum fluctuations magnified by the universe's rapid inflation. A patch this vast and this cold is an extreme statistical outlier. When astronomers calculate the odds of such a feature appearing by pure random chance, the numbers are staggeringly low. Some estimates place it at around 1 in 200. While not impossible, it's improbable enough to make scientists wonder if something more fundamental is at play. A cosmic event that left a permanent chill on the edge of space and time. One of the leading natural explanations points to a phenomenon called the integrated Sachs-Wolf effect. This occurs when light traveling through the universe passes through regions of changing gravitational potential. Imagine a photon of light from the CMB heading toward us for over 13 billion years. If it passes through a vast, mostly empty region of space known as a supervoid, it must climb out of the gravitational well of that void. In a universe dominated by matter, the well would deepen as the photon traveled through it, and the energy lost climbing out would be regained. But in our universe, which is dominated by dark energy causing an accelerated expansion, the gravitational well actually becomes shallower while the photon is inside it. The photon loses energy climbing out but doesn't regain it all, causing it to appear slightly redder and colder to our telescopes. So, the theory goes, the cold spot could simply be the shadow of the largest supervoid we've ever imagined, a billion light-year-wide expanse of cosmic nothingness. The problem: finding this proposed supervoid has proven incredibly difficult. While some large under-dense regions have been identified in the general direction of the cold spot, none have been found that are both large enough and empty enough to account for the profound temperature drop we observe. The void would need to be so tremendous and so utterly barren that its existence might be just as anomalous as the cold spot itself. The lack of a definitive void has led some cosmologists to propose a theory that is far more radical, an idea that comes from the very frontier of physics, the multiverse. This hypothesis suggests the cold spot is not a shadow, but a bruise. According to some models of eternal inflation, our universe is just one bubble in a vast, frothing multiverse of other bubble universes. If, during the universe's earliest moments, another bubble universe very nearly collided with ours, the energy released at the boundary of that collision could have left a distinct imprint on our CMB. The cold spot would be the cosmic scar from that event, a place where our universe brushed against the laws of physics of another reality. It's a breathtaking concept, that we might have observational evidence for a parallel universe, but it remains highly speculative and is, by its very nature, almost impossible to verify. Each potential explanation, from the statistical fluke to the supervoid to the multiverse collision, comes with its own significant challenges. The fluke seems too unlikely. The supervoid remains elusive. The multiverse theory, while thrilling, currently resides in the realm of untestable metaphysics. This leaves the cosmic cold spot as one of cosmology's most persistent and intriguing puzzles. It is a cold case in every sense of the word, a deep freeze that has resisted explanation for years. Whether it ultimately reveals a new aspect of dark energy, forces us to revise our models of inflation, or provides our first glimpse into a wider multiverse, its enduring presence on our universal map is a powerful reminder that the oldest light we can see still has profound secrets to tell. From the vast, cold imprint left on the edge of the observable universe, we now turn our attention to a galactic marvel that feels almost intimate by comparison. A celestial bullseye of such perfect form it looks like it was painted onto the cosmos. In the constellation Serpens, 600 million light-years away, floats a galaxy so unique that for decades after its discovery, astronomers weren't even sure how to classify it. This is Hoag's object, and it is a sight to behold. Through a telescope, it appears not as a spiral or an ellipse, but as a stunningly perfect ring of brilliant blue light encircling a radiant, golden core. The two are separated by a gap so dark and seemingly empty, it feels like a cosmic moat, a void deliberately placed to keep the old and the new apart. It is a galaxy that defies the standard categories, a rare ring galaxy that stands as one of the most structurally perfect objects in the entire universe. The beauty of Hoag's object lies in its stark contrast. The central core is a dense sphere of population 2 stars, ancient suns burning with a warm yellow light. These are stars that are billions of years old, containing very few heavy elements, the first generation to ignite in this island universe. They represent the galaxy's ancient heart. Surrounding them is a dazzling ring of intense, blue light. This is the signature of population 1 stars, young, massive, and hot. These are stellar newborns, blazing with ferocious energy and lighting up the vast clouds of gas and dust from which they recently formed. This ring is a stellar nursery on a colossal scale, a place of frantic, ongoing creation. And between these 2 worlds of old and new rests a profound darkness, a gap that appears almost completely devoid of any stars or luminous matter, making the entire structure look less like a naturally formed galaxy and more like a piece of divine jewelry. So how does such a perfectly symmetrical structure come to be? The most widely accepted theory is one of cosmic violence, a galactic collision. Billions of years ago, the story goes, a smaller dwarf galaxy might have plunged directly through the heart of what was then a more common spiral or disk galaxy. This catastrophic event would have sent immense ripples, density waves of gas and dust propagating outward through the victim galaxy, much like a pebble dropped in a pond. As these waves expanded, they compressed the interstellar material in their path, triggering a frenzy of star formation in a precise, circular ring. The central core, largely unaffected by the gravitational turmoil, would have remained intact, leaving behind the distinct separation we see today. This pebble in a pond model is elegant and is supported by computer simulations that can produce similar ring structures. However, a closer look at Hoag's object raises troubling questions for this neat explanation. The ring is phenomenally symmetrical and circular, with no signs of the distortions or tidal tails, the streams of stars ripped loose by gravity, that are the usual calling cards of a recent galactic merger. Furthermore, despite exhaustive searches, astronomers have found no visible remnant of the invading dwarf galaxy that supposedly caused the collision. It seems to have vanished without a trace. This pristine perfection suggests that if a collision did occur, it happened so long ago that all evidence of the perpetrator has since dissipated, leaving behind only this beautiful, circular scar as a testament to the ancient violence. This lack of clear evidence has given rise to alternative theories. Some suggest that Hoag's object could be the result of an extreme form of secular evolution, where a gravitational instability within a barred spiral galaxy causes its arms to spread out and connect, forming a ring. Others have proposed it might be the product of a rare resonance, a specific and stable orbital configuration between the stars and the galaxy's own gravitational field that naturally funnels star-forming material into a narrow, circular band. But no theory yet perfectly accounts for the vast, clean gap and the object's overall isolation. Adding another layer to the mystery, a follow-up deep field image revealed another, fainter ring galaxy, a potential Hoag's object in its own right visible through the gap, lying even further in the distance. This suggests that while individual ring galaxies are incredibly rare, the conditions that form them might be a recurring, if uncommon, theme in the universe. Hoag's object remains a breathtaking anomaly because it represents a moment frozen in time. It is a galactic portrait capturing 2 distinct eras simultaneously: the ancient, quiet core of its origins and the brilliant, young ring of its more recent rebirth. It challenges our understanding of galactic dynamics and evolution, proving that the processes that shape galaxies can, under the right circumstances, produce works of art of impeccable geometry. It is a reminder that the universe is not only a place of chaos and violence, but also one of unexpected and profound order. After marveling at the geometric perfection of Hoag's object, we venture into a realm of cosmic existence that is almost its complete opposite, not a galaxy of brilliant light and elegant structure, but a ghostly, ethereal specter that is barely there at all. This brings us to the profoundly strange case of Dragonfly 44, a galaxy that shouldn't exist, a celestial phantasm that is almost entirely made of nothing. Discovered lurking within the Coma cluster, a dense gathering of galaxies over 300 million light-years away, Dragonfly 44 was found not by the light it emits, but by the light it barely does. It is known as an ultra-diffuse galaxy, a class of objects so wispy and faint they are nearly transparent. If you were to float next to it, you would hardly know it was there. Its stars are so few and far apart that the galaxy is little more than a faint cosmic smudge. And yet, this apparent ghost holds a monstrous secret. By studying the motions of its sparse, lonely stars, astronomers made a shocking calculation. Those stars are whipping around at velocities that are simply impossible unless the galaxy is anchored by a truly gargantuan amount of mass, a gravitational anchor hidden from view. The conclusion was inescapable. Despite having a tiny fraction of the stars found in our Milky Way, Dragonfly 44 has roughly the same total mass. This means that over 99% of this galaxy is not made of stars, gas, or dust. It is made of one thing and one thing only: dark matter. This revelation turns the entire story of galaxy formation on its head. In our standard model, a galaxy's visible structure, its stars and nebulae, is a direct reflection of its underlying dark matter foundation. A massive dark matter halo, the theory goes, pulls in enough gas to birth a correspondingly massive population of stars. A galaxy with the mass of the Milky Way should look like the Milky Way, a brilliant pinwheel of hundreds of billions of suns. Dragonfly 44 shatters that expectation. It possesses the immense gravitational framework of a giant spiral, but it built almost nothing on it. It is a cosmic desert in the middle of a fertile plain, a skyscraper's foundation with only a small shed built on top. The fundamental question is, why? What catastrophic event or innate property prevented this galaxy from turning its vast reservoirs of dark matter and gas into the blazing stars we would expect? Astronomers are investigating several compelling and unsettling possibilities. One leading theory is that Dragonfly 44 is a failed galaxy. It may have formed early in the universe, collecting its immense dark matter halo and a huge supply of gas, only to have that star-forming fuel stolen away. Its location in the crowded Coma cluster is a key clue. As it plunged through the dense, hot intergalactic plasma at the cluster's heart, a process called ram pressure stripping could have violently torn away its gas, much like wind rips leaves from a tree. Robbed of its raw material, the galaxy was left permanently stunted, a dark matter skeleton with no way to flesh itself out. Another theory suggests it might be a pure dark matter galaxy, an object that formed in a region of the universe that was simply too devoid of the normal baryonic matter needed to make stars. It would be a galaxy born from darkness, destined to remain that way. The existence of Dragonfly 44 and other galaxies like it provides astronomers with a unique and powerful laboratory for studying dark matter. Because it is so dominantly composed of the mysterious substance, with very few stars to complicate the gravitational picture, it offers an incredibly clean signal. By mapping the motions of its stars, scientists can essentially map the distribution of its dark matter halo with unprecedented precision, testing theories about how dark matter particles behave and interact with each other. Does the dark matter in Dragonfly 44 clump at the center as our models predict? Or does it tell a different story? This ghostly galaxy is therefore more than just a curiosity. It is a natural experiment, a testbed for the most elusive substance in the universe. Its discovery forces us to expand our definition of what a galaxy even is. We can no longer picture them solely as islands of light. The cosmos is also populated by these shadowy giants, vast kingdoms of dark matter that rule through gravity alone. Their few stars merely lonely sentinels marking an invisible empire. Dragonfly 44 proves that for every brilliant spiral like our own, there may be a dark, silent twin, a hidden counterpart that embodies the overwhelming dominance of the dark universe over the visible one we call home. Moving from the ethereal, dark matter-dominated forms of galaxies like Dragonfly 44, we now turn our attention to a far more tangible, yet equally mysterious, cosmic phenomenon, one that involves not the absence of matter, but its deliberate and dramatic creation. In the dense, ancient heart of our own Milky Way, astronomers have recently identified a completely new class of stellar elders, stars that behave less like serene suns and more like moody, cosmic dragons. They are known as the Old Smoker stars, and their discovery adds a fascinating and unexpected chapter to the story of how the galaxy seeds itself with the very ingredients for life. These aren't the violent, short-lived supernova that dominate headlines. Old Smokers are a different kind of stellar citizen entirely. They are ancient red giants, suns that have exhausted their hydrogen fuel and are in the final, bloated stages of their long lives. For decades, perhaps even centuries, they will sit quietly, burning dimly. Then, without any clear warning, they erupt. But instead of blasting out energy and light, they do something far more peculiar. They belch out incredibly dense clouds of smoke and dust. These aren't mere puffs. The ejecta are so thick and voluminous that they completely shroud the star from view, rendering it virtually invisible to optical telescopes for years, sometimes even decades at a time. It's as if the star pulls a sooty blanket over itself and goes into hibernation, only to re-emerge later, seemingly unchanged, as the cloud slowly dissipates. This behavior is utterly unlike the predictable pulsations of known variable stars or the explosive finality of a supernova. It is a slow, secretive, and repetitive process of self-obscuration. The significance of these smoky eruptions goes far beyond mere stellar eccentricity. This cosmic soot is not just any dust. It is stardust in the most literal sense. Within these clouds are vast quantities of complex molecules and heavy elements forged in the nuclear furnaces of these aging stars. Elements like carbon, the fundamental building block of life as we know it, are churned up from the star's interior and launched into the interstellar medium inside these protective cocoons of smoke. This delivery mechanism might be crucial. Throwing these precious elements directly into the harsh environment of space, with its relentless ultraviolet radiation from nearby young stars, could break them apart before they have a chance to coalesce into something more. But by encasing them in a thick shell of dust, the Old Smoker star is essentially packaging them for safe delivery. It is a cosmic courier service, ensuring that these vital materials survive their journey across the galaxy to eventually become part of new planetary systems, and perhaps the foundation for future biology. This discovery forces a major rethink of stellar evolution for sun-like stars. We thought we had the life cycle of a red giant fairly well mapped. A steady expansion, followed by a more dramatic but predictable shedding of its outer layers to form a beautiful planetary nebula. The Old Smokers don't follow this script. Their eruptions are violent yet contained, significant yet not terminal. Why do only some red giants behave this way? The leading hypothesis points to their location. These stars are predominantly found near the crowded galactic center, a region rich in metals, the astronomers' term for elements heavier than hydrogen and helium. It's possible that this metal-rich environment influences the complex physics occurring within the star's convective outer layers, allowing pockets of material to build up and be ejected in these discrete, powerful belches. Their advanced age is also a key factor. They are among the oldest stars in the galaxy, and their internal dynamics may be governed by rules we are only beginning to understand. Unraveling the mystery of the Old Smokers requires patience, a virtue in short supply in our fast-paced world. Because their dimming events unfold over such long timescales, It took a dedicated 10-year survey of the galactic bulge to even identify them, separating their slow, deliberate fade from the more rapid flickering of other variable stars. Their discovery is a powerful testament to the fact that even within our own galaxy, there are still profound secrets waiting to be found, not in the brilliant explosions, but in the long, slow, quiet breaths of its oldest inhabitants. These stars are the galaxy's recyclers, its sooty, ancient artisans, working in the shadows to distribute the elements of life, reminding us that cosmic creation is often a slow, messy, and hidden process. Our journey through the cosmos's oddities now brings us closer to home, to an object so familiar we often take it for granted, yet it holds a secret that has left planetary scientists utterly baffled. Gaze up at the moon on a clear night. It is a world of silent seas and cratered highlands, a desolate and seemingly frozen relic of the past. For centuries, we saw it as a geologically dead world, its history written solely in the dust of its surface. But that perception was shattered when Apollo astronauts brought back samples of lunar rock. Locked within those ancient stones was a record of a past far more dynamic and powerful than anyone had imagined. These rocks were magnetized. They revealed that the moon, for the first billion years of its life, possessed a magnetic field. Not a weak, token force, but a global dynamo that may have been even stronger than Earth's is today. This presents us with a profound mystery. How could a world with such a small, likely solid iron core have generated such a powerful planetary shield? The very existence of a lunar dynamo flies in the face of what we know about how magnetic fields are made. On Earth, our protective magnetic shield is generated by a powerful dynamo effect in the outer core. This requires a specific recipe: a liquid, electrically conductive iron core that is rotating and churning due to convection, moving heat from the inner core outwards. It's a massive, self-sustaining engine. The moon, however, is a tiny world. Its core is small, estimated to be only about 500 kilometers across. Basic models suggest that such a small core should have cooled down and solidified completely within a few 100 million years of the moon's formation, roughly 4.5 billion years ago. Without a churning, liquid outer core, the dynamo engine should have sputtered out almost immediately. And yet, the Apollo samples tell a different story. The magnetic record in those rocks shows that the lunar dynamo was not only active, but also surprisingly long-lived, persisting for over 1 billion years, and was at its peak strength around 3.5 to 4 billion years ago. It's the equivalent of finding a small campfire that somehow burned brighter and longer than a massive forest blaze. The puzzle is not just why it turned on, but how it sustained itself for so long against all odds. Planetary scientists have proposed several compelling and quite creative theories to power this impossible engine. One of the leading ideas involves the moon's unique wobble. Billions of years ago, the moon was much closer to Earth, and its orbit and interior were vastly different. This theory suggests that the gravitational tug of war with Earth caused the moon's solid mantle to subtly wobble, or precess, around its rotation axis. This motion, like a spinning top slowly winding down, could have mechanically stirred the liquid portion of the core, churning it like a spoon in a cup. This mechanical stirring could have provided the necessary energy to drive a dynamo, even in the absence of the strong heat-driven convection we see on Earth. It's an elegant solution that ties the dynamo's existence directly to the moon's orbital dance with our planet. Another theory points to cataclysm. The ancient moon was bombarded by a rain of massive asteroids, the impacts of which carved out its great basins like Mare Imbrium. These weren't just surface events, they were planet-shaking blows. The theory proposes that these colossal impacts could have created massive imbalances in the moon's interior, shifting the density of the mantle in a way that would have radically altered the flow of heat from the core. Imagine shaking a bottle of soda. The sudden release of pressure causes a violent reaction. In a similar way, these impacts might have temporarily disrupted the core's stable state. unleashing a surge of buoyant material that powered the dynamo for a short, intense period after each major impact. This could explain the surprising strength of the field recorded in the rocks, coinciding with the era of heaviest bombardment. Why does this ancient lunar puzzle matter to us today? Because the story of the Moon's magnetic field is inextricably linked to our own planet's history. The Earth and the Moon have been a coupled system since the giant impact that formed them. Understanding the energy sources and thermal evolution of the Moon's interior provides a critical mirror for understanding the early Earth. Furthermore, a strong magnetic field would have protected the lunar surface from the full onslaught of the solar wind during that first billion years. This could have prevented the solar wind from implanting certain elements into the lunar soil, changing the very chemistry of the surface we study today. It also paints a picture of a far more dynamic early Moon, a world with a molten, churning heart that powered not only a magnetic field but also significant volcanic activity, shaping the world we see today. Solving the mystery of the magnetic Moon is about more than just understanding a lunar engine. It's about finding a missing piece in the story of our entire cosmic neighborhood. A reminder that even the quietest of worlds can have a surprisingly turbulent past. But just when we think we understand the final, explosive act of a star's life, the universe delivers a performance that rewrites the entire script. In the annals of cosmic cataclysms, few events have proven as bewildering and as stubbornly defiant of explanation as the supernova known as IPTF-14 Discovered in 2014 by the Intermediate Palomar Transient Factory Survey, it initially appeared to be a completely ordinary, if somewhat late, stellar explosion. But as astronomers continued to watch, this stellar death revealed itself to be anything but ordinary. It was, in fact, a star that refused to die, a cosmic phoenix that exploded, faded, and then exploded again and again over an incredible period of more than half a century. The first clue that IPTF-14 was an imposter came from its light curve. A typical supernova follows a predictable pattern: a sharp, brilliant rise to a peak brightness, followed by a steady, irreversible decline over a period of weeks or months, as the radioactive elements forged in the explosion decay and the expanding cloud of debris cools. This supernova did not obey those rules. After its initial peak in 2014, it began to fade as expected. But then, something miraculous happened. Instead of continuing its descent into darkness, its light curve plateaued, then surged back to peak brightness not once, but at least 5 separate times over the next 2 years. It was as if the star was having multiple violent outbursts, a series of energetic hiccups that kept it shining brightly long after it should have burned out. This bizarre behavior alone was enough to mark it as a profound anomaly. Then, researchers made an even more astounding discovery. By digging through historical astronomical archives, they found a photographic plate of that exact same patch of sky from the year 1954. And there it was, a clear, bright point of light exactly where IPTF-14 would later explode. The star had survived a massive eruption 60 years prior, an event that for any other star would have been its final, terminal supernova. Somehow, it had endured that cataclysm, held itself together, and lived to explode another day, several days in fact. This wasn't just a supernova. It was a supernova that had happened multiple times, a star that had cheated death on a scale never before witnessed. The energy required to power this decades-long light show was simply staggering. Calculations suggest the total energy output was at least 10 times that of a normal supernova, and potentially 100 times greater. This forces us to confront a fundamental question: what kind of stellar engine could possibly produce such an immense, sustained, and intermittent release of power? The leading hypothesis, though still hotly debated, points to one of the most extreme theoretical events in astrophysics: a pulsational pair instability supernova. This scenario involves a true behemoth of a star, one born with a mass between 95 and 130 times that of our Sun. In the core of such a monster, temperatures and pressures become so insane that the energy of gamma-ray photons spontaneously converts into pairs of electrons and their antimatter counterparts, positrons. This conversion is a catastrophic theft of the radiation pressure that is holding the star up against its own immense gravity. Without that outward pressure, the core suddenly collapses, triggering a violent thermonuclear explosion. But in this model, the explosion is not quite strong enough to completely unbind the entire star. It instead blows off the star's outer layers in a massive eruption, while the inner core survives, cools, and continues its life. The process can then repeat itself decades or centuries later, as the core continues to fuse elements and build towards another instability. IPTF-14HLS could be the first real-world observation of this theoretical fireworks display, a star suffering through multiple partial explosions before its final, total collapse. Other theories are equally captivating, if not more so. Some astronomers propose that we witnessed the death of a supermassive star, a celestial titan with a mass of up to 1,000 suns, a relic from the very early universe. The death throes of such an object are beyond our current models. As its core collapsed into a black hole, the infalling matter could have formed an immense, swirling accretion disk that launched jets at near light speed. If one of those jets was pointed directly at Earth, we would see an incredible, long-lasting burst of energy as the jet interacted with the material previously ejected from the star. This could explain the multiple peaks and the astonishing energy budget. Another, even more exotic idea suggests the supernova debris might have fallen back onto a newly formed neutron star, powering it like a zombie star that continues to feed on its own remains. Ultimately, IPTF-14HLS stands as a humbling reminder of the limits of our knowledge. It did not neatly fit into any of the boxes we had prepared for stellar death. Its very existence forces astronomers to reconsider the final moments of the most massive stars, suggesting that their demise can be a far more complex, drawn-out, and energetic process than our textbooks ever described. It is a cosmic outlier that challenges us to invent new physics, to imagine more creative and violent ends for stars, and to accept that even the most well-established cosmic events can still hold spectacular secrets. And just when we think we understand the fundamental building blocks of the universe, we find that one of the most common and yet most elusive particles is behaving in ways that defy our most precise predictions. This brings us to a mystery so subtle it's conducted in massive underground laboratories, a puzzle centered on particles so ghostly they pass through our planet as if it weren't even there. We're talking about neutrinos, and their strange behavior is pointing toward the existence of an entirely new, shadowy form of matter. To understand this anomaly, you first have to appreciate just how bizarre neutrinos are. They are among the most abundant particles in the universe, yet they are famously aloof. Trillions of them are streaming through your body every second, coming from the sun, from cosmic rays, and from distant cataclysms. They have almost no mass and no electric charge, which means they barely interact with anything at all. They are cosmic phantoms, but they do have one fascinating quirk: they change identity. As they travel, neutrinos oscillate between three known types, or flavors: the electron neutrino, the muon neutrino, and the tau neutrino. This oscillation is a confirmed and beautiful piece of quantum weirdness. However, multiple independent experiments have now observed a persistent glitch in this quantum dance. The number of neutrinos that oscillate, and the way they do it, doesn't match our theoretical models. There's a discrepancy, a missing piece in the equation, and it suggests that our trio of neutrinos might be hiding a secret fourth sibling. This hypothetical particle has been dubbed the sterile neutrino. The name says it all. Unlike its three cousins, a sterile neutrino wouldn't interact through any of the fundamental forces of the standard model of particle physics. Not the weak force, not the electromagnetic force, not even the strong force. Its only way of making its presence known would be through the most subtle force of all, gravity. You cannot build a detector to catch it directly, because it would simply ignore the detector and pass right through. We could only infer its existence by the gravitational tug it exerts, and more tantalizingly, by the way it subtly influences the oscillation patterns of the regular neutrinos we can detect. It would be a true ghost, a particle from the shadows, forever hidden from our view but shaping the behavior of the world we can see. The implications of such a discovery would be nothing short of revolutionary. First, it would be the first major expansion of the Standard Model in decades, forcing a complete rewrite of our most fundamental understanding of particle physics. But the ripple effects would extend far beyond the atom. This sterile neutrino is a prime candidate to explain one of cosmology's biggest mysteries, dark matter. If these particles have the right mass, they could be the invisible, massive stuff that makes up over 80% of the matter in the universe. It's gravitational glue holding galaxies together. Finding evidence for sterile neutrinos could, in one stroke, solve two of the biggest puzzles in modern science. Yet, for all its promise, the sterile neutrino remains a specter, a theory caught in a web of conflicting evidence. This is where the mystery deepens from a thrilling possibility into a frustrating enigma. The initial hints came from experiments like the Liquid Scintillator Neutrino Detector, or LSND, at Los Alamos National Laboratory in the 1990s, and later from the Mini BUENI experiment at Fermilab. These projects were designed to study neutrino oscillations over short distances, and both detected a significant excess of neutrinos of a certain flavor, more than the three-neutrino model could account for. This was the first major day, a point suggesting a fourth actor was involved. However, other incredibly precise experiments have failed to see this effect. Projects like the IceCube Neutrino Observatory, a massive detector buried deep in the Antarctic ice, and the Sudbury Neutrino Observatory in Canada have looked for signs of sterile neutrinos and found nothing. Their results are perfectly consistent with the standard three-neutrino model, so we are left with a classic scientific standoff. One set of experiments insists something is wrong, pointing insistently at an anomaly. Another set of equally rigorous experiments confirms that our original model holds up just fine. This leaves physicists in a state of intense and productive uncertainty. Either there is a subtle systematic error in the experiments seeing the anomaly, or there is a deeper layer of physics we don't yet understand that explains why the effect is visible in some setups and not others. The hunt is now on to resolve this discrepancy. A new generation of experiments, like the upcoming JSNS Squared in Japan and the Prospect experiment at Oak Ridge National Laboratory, are being meticulously designed to probe this exact energy and distance range with unprecedented precision. They aim to either finally confirm the existence of the sterile neutrino or definitively lay the anomaly to rest. This is how science operates at the frontier. It's a slow, careful process of interrogation, where every potential discovery is met with rigorous skepticism. The story of the sterile neutrino is a perfect example of this beautiful tension, a compelling hint that pulls us toward a new reality, held in check by the unwavering standards of evidence that prevent us from rushing headlong into error. It is a ghost we are still learning how to hunt. Imagine you're trying to measure the growth of a tree. You have two methods. One is to count the rings in its trunk, a record of its entire history. The other is to measure its height right now and compare it to a photograph from a few years ago. In a stable, predictable world, both methods should give you the same growth rate. But what if they didn't? What if the tree's rings told one story of its life, while your direct measurements told a completely different, faster story? This isn't a botanical puzzle. It's the precise and deeply unsettling situation cosmologists find themselves in when trying to measure the expansion of the entire universe. The growth rate we're talking about is called the Hubble constant. And the fact that we get two different answers depending on how we measure it is one of the most significant crises in modern cosmology. It's a discrepancy so persistent and so serious that it has earned its own dramatic name, the Hubble tension. Our first method for measuring the universe's expansion is like reading the cosmic tree rings. We look back to the very infancy of the universe, to the cosmic microwave background radiation. This afterglow of the Big Bomb, frozen in time when the universe was just 380,000 years old, is our most pristine snapshot. By studying the tiny fluctuations in this radiation with exquisite precision, most famously with the Planck satellite, we can extrapolate the entire history of cosmic expansion. We can plug these measurements into our standard model of cosmology, the lambda cold dark matter model, and it spits out a very precise value for the Hubble constant, about 67 kilometers per second per megaparsec. In simpler terms, this means that for every megaparsec, a distance of about 3.3 million light-years, a galaxy is from us. It should be moving away from us at 67 kilometers per second. This is the universe's expansion rate as told by its ancient baby pictures. Our second method is like taking that modern measurement of the tree's height. We look at the universe as it is today, using what astronomers call the cosmic distance ladder. We start with reliable markers like Cepheid variable stars, whose known brightness allows us to gauge distances to nearby galaxies. We then use those galaxies to calibrate the true brightness of Type Ia supernova, the incredible stellar explosions that serve as standard candles across vast cosmic distances. By measuring how much the light from these supernovae has been stretched or red-shifted by the expansion of space, we can directly calculate the Hubble constant in our local, modern universe. Teams like the one led by Nobel laureate Adam Rees using the Hubble Space Telescope have done this with phenomenal accuracy, and their answer is consistently different, about 73 kilometers per second per megaparsec. The universe today appears to be expanding significantly faster than the baby pictures say it should be. The difference between 67 and 73 seems small, but in the world of high-precision cosmology, it's a chasm. The error bars on each measurement have been squeezed so tight that they no longer overlap. This is not a case of sloppy math or fuzzy data. It is a genuine, stubborn discrepancy that has survived over a decade of repeated testing and improved technology. This Hubble tension is now at a confidence level of 5 sigma, meaning there is only a 1 in a million chance that it's a random fluke. It is a real problem. And it strongly suggests that something is missing from our otherwise incredibly successful standard model of cosmology. This is where the anomaly points directly at the greatest mystery in physics: dark energy. We know dark energy is the name we give to the mysterious force causing the universe's expansion to accelerate, but we don't know what it is. The lambda in our cosmological model represents a constant, unchanging form of dark energy. But what if dark energy isn't constant? The Hubble tension could be a giant clue that our simple idea of dark energy is wrong. Perhaps dark energy is dynamic, evolving and growing stronger over time. Maybe it's a new field that interacted differently with the early universe than it does today. Some theories even suggest a brief episode of early dark energy that subtly altered the conditions captured in the cosmic microwave background, throwing off our extrapolation to the present day. If the force of dark energy is changing, it would mean the fate of the cosmos is far less certain than we thought. Instead of a long, slow, cold expansion into nothingness, we could be headed for a far more dramatic end, perhaps even a big rip where the accelerating expansion eventually tears apart galaxies, stars, and even atoms themselves. Other explanations are even more radical, pointing to a need for new physics beyond our current understanding. Could there be a new type of subatomic particle, like a dark radiation, that flooded the early universe and changed its expansion history? Or could the elusive neutrino have properties we haven't yet accounted for that would resolve the tension? The most extreme possibility is that we are seeing the first cracks in Einstein's theory of general relativity, suggesting that our understanding of gravity itself needs to be modified on the largest cosmic scales. Each of these ideas is a potential path to a revolution in physics, and the Hubble tension is the signpost pointing us down that road. It is a cosmic anomaly that refuses to be ignored, a persistent whisper in the data that tells us our map of the universe, for all its detail, is still missing a few fundamental landmarks. The ultimate fate of everything, the final destiny of all galaxies, stars, and time itself may hinge on solving this single, pressing mystery. From the grand, universe-spanning tension of the Hubble constant, we now turn our focus to a cosmic mystery that unfolds in the blink of an eye. A burst of energy so intense it can outshine 500 million suns. These are fast radio bursts, or FRB. For a few fleeting milliseconds, a torrent of radio waves screams across the cosmos, a blast of energy that often travels for billions of years before our telescopes catch its final, dying whisper. For a long time, the most baffling thing about these events was their singularity. They would flash once from a random point in the sky and then vanish forever, leaving astronomers with a frustratingly brief signal and no way to ever hear it again. They were the ultimate cosmic one-hit wonders, but then we found the repeaters. A small but fascinating subset of these FRBs don't just fire once, they fire again and again. They are the persistent enigmas of the radio sky, sending out their incredibly powerful signals in unpredictable patterns. Some might go quiet for weeks or months, only to suddenly erupt in a flurry of activity. Others might release a single, powerful burst, and then follow it up with a series of weaker, fainter pops. This repetitive behavior is the single most important clue we have in unraveling their origin, because it immediately rules out any cataclysmic, one-time event. You can't have a repeating supernova or a recurring black hole merger. Those are final, terminal acts. Whatever is creating these repeating FRBs must be capable of surviving its own outburst, a cosmic engine that can unleash a staggering amount of energy and then simply reset itself to do it all over again. The prime suspect in this cosmic whodunit is one of the most extreme objects known to physics, a magnetar. Imagine taking the mass of a star and crushing it down into a city-sized ball, then spinning it faster than a kitchen blender and endowing it with a magnetic field so powerful it could erase your credit card from 500,000 miles away. This is a magnetar, a highly magnetized neutron star. The conditions on and around such an object are almost unimaginably violent, a perfect crucible for generating enormous bursts of energy. The leading theory suggests that these magnetars can experience starquakes, sudden fractures in their incredibly rigid, crystalline crust. As the crust snaps and shifts under the strain of its own unimaginable magnetic field, it could release a massive flare of energy that we detect as an FRB. Alternatively, the immense magnetic fields could trap an atmosphere of superheated plasma, which then becomes unstable and collapses in a sudden avalanche onto the star's surface, releasing the burst of radio waves. These models work because a magnetar can experience these events repeatedly. Its crust can crack over and over, and its magnetosphere can trap and release plasma in a continuous cycle. The case for magnetars received a monumental boost in 2020, when fortune handed astronomers a gift from our own cosmic backyard. A known magnetar within our own galaxy, named SGR 1935 plus 215, entered an extremely active period, erupting with a series of powerful X-ray and gamma-ray bursts. As telescopes around the world swiveled to observe it, something incredible happened. The Canadian CHIME radio telescope and the STARE 2 instrument in the US both detected an extremely bright radio burst emanating from this exact same magnetar. For the first time ever, an FRB had been definitively pinned to a specific source within our own galaxy. This was the smoking gun. It proved, beyond a reasonable doubt, that at least some FRBs, and by extension likely the repeating ones, are indeed generated by magnetars. Yet, as is so often the case in astronomy, answering one question immediately opened up several more. While we now have a likely culprit, the exact murder weapon, the precise physical mechanism that transforms a stellar quake or a magnetic avalanche into such an intense, coherent burst of radio energy remains elusive. The energy and the rapid timescales are incredibly difficult to model. Furthermore, the existence of repeaters raises a new puzzle. Why do some magnetars produce FRBs while others do not? Is it a question of age, magnetic field strength, or perhaps the environment surrounding the star? Some of the most energetic repeating FRBs seem to come from sources embedded in very unusual, turbulent environments, suggesting they might be young magnetars still shrouded in the debris of the supernova that formed them. This lingering uncertainty is what keeps the door open for more speculative and thrilling possibilities. Could some of the most complex and repeating FRB patterns be evidence of something beyond natural astrophysics? It's a question that, while far less likely, is impossible to completely dismiss when faced with such a potent and mysterious signal. The repeating nature of these bursts, with their sometimes seemingly coded patterns, has inevitably led to speculation about artificial origins. Could they be the lighthouse beams of an unimaginably advanced civilization, used for propulsion or for galaxy-spanning communication? While the magnetar explanation is overwhelmingly the most plausible, the sheer power and mystery of these repeating bursts ensure that all possibilities, no matter how remote, remain a part of the conversation, a testament to their ability to capture our imagination and push us to the very limits of our understanding. They are a reminder that even with a suspect in custody, the mystery is far from completely solved. After delving into the mysteries of fleeting radio bursts and the fundamental tension in our universe's expansion, we now turn our search inward, to the seemingly familiar space of our own solar system. Here in the dark, frozen reaches far beyond Neptune, an anomaly of gravity and motion suggests that our planetary family might not be complete. This is the compelling and controversial hypothesis of Planet 9. The story doesn't begin with a glimpse of a new world, but with the peculiar behavior of those we already know exist. Astronomers studying the Kuiper Belt, that vast disk of icy debris left over from the solar system's formation, noticed something strange about the most distant of these objects, known as extreme trans-Neptunian objects or ETNO. These frozen remnants, like Sedna and a handful of others, have incredibly long, elliptical orbits that take them hundreds of astronomical units from the Sun. But their paths aren't just random, they are curiously clustered. Their orbits are aligned, their points of closest approach to the Sun grouped together in space, and their planes tilted in a similar way. This clustering is statistically bizarre. In a stable, well-understood solar system governed primarily by the known planet's gravity, these orbits should be oriented randomly. The odds of this alignment happening by pure chance are astronomically low, perhaps less than 1 in 10,000. It's as if an unseen shepherd is herding them, using its immense gravitational pull to corral their paths. The leading explanation for this herding effect is a large, undiscovered planet. This hypothetical world, dubbed Planet 9, wouldn't be a small, rocky body like Pluto. Calculations suggest it would be a true giant, a super-Earth or a mini-Neptune with a mass somewhere between 5 and 10 times that of our own planet. Its orbit would be equally colossal and incredibly distant. Scientists propose it could orbit the Sun at an average distance of 4 to 500 astronomical units. To put that in perspective, that's over 10 times farther out than Neptune and about 13 times farther than Pluto at its most distant. A single year on this world would be staggeringly long, taking perhaps 10 to 20,000 Earth years to complete one frigid journey around the Sun. Its influence would be subtle but profound, its gravity gently tugging on the ETNO over immense timescales, slowly sculpting their orbits into the strange alignment we observe from afar. The hunt for this phantom world is one of the great modern astronomical quests. Teams are using the world's most powerful telescopes, like Subaru in Hawaii, to meticulously scan the vast proposed orbital path, looking for a single, faint point of light moving slowly against the background stars. It's a painstaking process, like searching for a single specific grain of black sand on a dark beach at night. The challenge is immense. At that distance, even a large planet would reflect very little sunlight, making it incredibly dim. Furthermore, its motion would be agonizingly slow from our vantage point, requiring observations spaced months or even years apart to confirm its movement. Yet, the Planet 9 hypothesis is not without its detractors, and compelling alternative explanations have emerged. The most significant of these is the argument that we are being fooled by a cosmic illusion, an observational bias. The reasoning goes that these distant, strange orbits only appear clustered because that's the only part of the sky we've looked at deeply enough to find them. Our telescopes have surveyed limited regions with the sensitivity needed to detect such faint objects. If we could see the entire sky with equal clarity, the argument suggests, we might find that these orbits are, in fact, randomly distributed, and the clustering is just a figment of our incomplete data. It's a classic case of not being able to see the forest for the trees, or in this case, the entire Kuiper belt for the few objects we've found. Other astronomers propose that the collective gravity of the Kuiper belt itself could be the culprit. While individual objects are small, the combined mass of countless unseen icy bodies, a population far larger than what we've currently catalogued, could exert a small but consistent gravitational tug. This distributed gravity might be enough to gently shepherd the orbits of the most distant objects, creating the observed alignment without the need for a single large planet. This idea turns the problem on its head, suggesting the anomaly isn't pointing to a new planet, but to a much larger and more massive Kuiper belt than we ever imagined. The intense debate surrounding Planet 9 is what makes it such a vital pursuit in modern astronomy. Proving its existence would be a monumental discovery, literally rewriting the textbooks on our solar system's composition and dynamic history. It would raise fascinating questions about how a large planet ended up in such a distant orbit. Was it ejected from the inner solar system in its chaotic youth? Or was it an interstellar rogue captured by the sun's gravity long ago? Conversely, definitively disproving it would be equally profound. It would force us to radically revise our models of how the outer solar system formed and evolved, and likely lead to the discovery of a much greater population of smaller objects than we thought possible. Whether it's a solitary giant or the subtle hand of a hidden multitude, the anomaly in the outer darkness is a powerful reminder that even our own cosmic neighborhood still holds tremendous secrets waiting to be uncovered. As we reach the end of our tour through these 25 cosmic puzzles, from the Great Attractor's pull to the phantom of Planet 9, it's worth pausing to ask what they all mean together. It would be easy to see this collection of mysteries as a list of science's failures, a catalog of everything we still don't understand. But that perspective couldn't be more wrong. In reality, each one of these anomalies is not a wall, it is a doorway. They are the very frontiers of knowledge, the places where our current models strain and crack, revealing the thrilling potential for a deeper truth waiting just beyond our grasp. The history of science is, in many ways, written by its greatest anomalies. Imagine if the slight wobble in Mercury's orbit had been dismissed as a mere calculation error instead of becoming a crucial piece of evidence that helped launch Einstein's theory of general relativity. Consider how the bizarre and seemingly impossible energy levels of beta decay led to the prediction of the neutrino, a ghostly particle we now know is fundamental to the universe's operation. Time and again, it is the thing that doesn't fit, the observation that refuses to conform, that forces a paradigm shift. These cosmic puzzles are the universe's way of tapping us on the shoulder and pointing out where our textbooks are incomplete. They are the questions that keep science alive, dynamic, and endlessly fascinating. This process of investigation, of chasing down a faint signal or a strange orbital alignment, has a way of creating ripples that transform our world. The tools we build to solve one mystery often become the instruments that unlock entirely new fields of discovery. The development of radio astronomy to listen to the heavens gave us the technology for modern satellite communication and medical MRI machines. The painstaking effort to measure the cosmic microwave background with exquisite precision pushed the limits of detector technology and cryogenics. The search for a sterile neutrino in underground labs advances our understanding of materials and radiation shielding. The pursuit of the answer itself forces innovation, building a ladder of technology that allows us to reach for the next question and the next. Perhaps the most profound lesson embedded in all of these enigmas is one of humility. They are a collective reminder that the universe operates on a scale and with a complexity that can dwarf human intuition. Our experience is limited to a narrow band of reality, a certain size, a certain timescale, a certain set of physical laws as we currently understand them. These anomalies scream to us that reality is far richer, far stranger, and far more wonderful than we could ever imagine from our tiny vantage point. The universe is under no obligation to conform to our expectations of what is normal or possible. It is a grand, chaotic, and spectacular experiment that we are only just beginning to observe. So the next time you hear about a star that mysteriously dims, a galaxy with no dark matter, or a signal from the deep that repeats, don't see it as a frustrating problem. See it for what it truly is, an invitation to wonder, to question, and to explore. These puzzles are the guiding stars for the next generation of scientists, the unsolved riddles that will inspire young minds to build better telescopes, devise grander theories, and venture further into the unknown. They assure us that no matter how much we learn, the cosmos will always have more secrets to share, more wonders to reveal, ensuring that the human journey of discovery is a story with no final chapter. From the strange hexagonal storm at Saturn's pole to the perplexing wanderings of Oumuamua and the haunting silence of the Fermi Paradox, we've journeyed through a gallery of the universe's deepest enigmas. We've stood in awe of structures so vast they defy logic, like the Boötes Void and the Great Attractor, and puzzled over the intimate quirks of our own solar system, from the Moon's lost magnetic field to the distant specter of Planet 9. These aren't mere gaps in our knowledge, they are cosmic signposts, pointing toward truths we have not yet begun to imagine. Each one, from the impossible star that exploded over and over to the ghostly galaxy, made almost entirely of dark matter, serves as a powerful testament to a universe that is wildly, wonderfully, and persistently stranger than fiction. This incredible journey reminds us that the pursuit of understanding is never complete. The greatest gift these mysteries offer is not a final answer, but an endless invitation to stay curious, to embrace the unknown, and to remain forever humbled by the sheer scale and complexity of the cosmos. Every time we solve one puzzle, the universe unveils two more, ensuring that the adventure of discovery will never truly end. So the next time you find yourself under a clear night sky, take a moment to simply look up. Let yourself wonder about the invisible forces, the hidden worlds, and the unanswered questions dancing in that expanse. Let that sense of mystery rekindle your own innate curiosity. Now we'd love to hear from you. Which of these 25 cosmic anomalies captured your imagination the most? Was it the eerie perfection of Hoag's object, the baffling signal of the Wow burst, or the terrifying scale of the dark flow? Share your thoughts in the comments below. And if you have another cosmic puzzle that fascinates you, let us know. For more deep dives into the secrets of the universe, make sure to subscribe and hit the bell so you don't miss our next exploration into the unknown. The cosmos is full of stories waiting to be told, and we're just getting started.